how do you, number one, get them to join your team? How do you recruit?
And then how do you bribery works best, but yeah, I don't.
Well, yeah, I mean, I get that. Welcome back to Emphasis Tech Talks, the podcast for business leaders leveraging cutting-edge technology to raise their bottom line. I'm your host, David Clausen of Emphasis Tech. Our guest today is Roy Robinson, co-founder and CTO at Excipio Energy. Today, we are going to talk about new advancements in the offshore energy sector and risk management. But be sure to stick around to hear his unique take on AI. Like and subscribe to make sure you get notified of future videos when they are released. Roy, thanks so much for joining us today. Appreciate you being here with us on the podcast.
My pleasure.
So, Roy, give me the real quick elevator pitch about your background and kind of your claim to fame here.
Sure. I come from a background of 25 years of building things offshore oil and gas. In 2016, I left that business and started Excipio Energy. Excipio stands for to capture in Latin, and that's what the company is meant to do. What we try to do is incorporate different systems together to make them far more economically viable than they would be alone. If any of the systems that are out there right now in terms of the offshore renewables really struggle to make profit, because the cost of installing them and permitting them and all those other things that you really can't change are really expensive if you're working offshore. And so for them to be competitive with the onshore stuff is very difficult.
And so you're introducing that competitiveness through technology, I assume?
A combination of things. The first thing we did, and the first patent that we have, is on a platform that integrates them all together. Because what happens is, if you're going to build a floating platform, once you've paid for the moorings and the installations and the permits and the insurance and the boats and everything else, whether it's got wind or whether it's got wind plus doesn't really matter. Doesn't change the cost that much. So those other devices, basically, the easiest way to think of it is they get a free ride. So if you take out their installation costs, then they're making energy that makes money. If you try to deploy a wave energy device on its own, it has to pay for the moorings and the permits and all that, and it doesn't make enough energy. Same goes with the tidal devices. Now that's the using other people's technology, and all we did was bring them all together. That does a lot more for the economics than you might think. Just by doing that, you can reduce the cost of the electricity you could sell from, say, compared to a wind turbine, down by 25 or 30%. On top of that, where we really have made the technology breakthrough is we have basically reinvented a 100-year-old technology called ocean thermal energy conversion. It's better known as OTEC. And the way that works is, if you have warm water on the surface and you have very cold waters in the deep, it's always about 4 degrees at the bottom of the ocean, you can actually boil ammonia in tropical waters at the 25 degrees. See, this is Celsius that it does. You run it through a steam turbine. You use that cold water to condense it, and just keeps going. So it's 24/7 power, invented in the 1890s by a French guy. There was one that was ever built commercially, lasted 4 months till a hurricane flattened it in Cuba. But that was back in the 1920s and 30s. People have tried to redo it since, but every time they do it, they've just been trying to do that technique, the techniques they had then, with new materials. And it didn't work. You can't make money with it. We redesigned it entirely. We pretended that we were having a glass of wine with a French inventor, and if he knew what we knew, how would he do it? And so, besides drinking some really good wine and some nice cheese, we would take the entire OTEC plant, the entire power plant, if you will, and place it on the seabed. Because in oil and gas now we can do that. We put a lot of the equipment on the seabed. That by itself doesn't do anything for you, because you still can't get there. What you need, and what holds them back, is this massive amount of water you have to move if you're just doing the 25 and that 4 degrees, right? So you're talking river-like flows of water. So for 100 megawatt OTEC, conventional OTEC, you'd need a 14-meter diameter cold water pipe bringing that cold water up to the surface. My background, like I said, is offshore pipelines, and I can design you that and I can build you that. But I can't design it and build it for something for the dollars that would be supported by only 100 megawatts of power. Just can't. You can't get there from here. By putting it on the seabed, instead of needing to do that, what we do is we have added a heat transfer loop. So basically, just like a heat pump in your house, we built the world's biggest heat pump. And what we do there is we take the warm water surface, heat it up, the fluid comes down, goes through the OTEC plant, runs it, comes back up. And in this case, that fluid that we're using to transfer the heat is CO2, right? So we're not moving water. And what that does is it also makes the pipe a lot smaller. Plus, it also does something else very important, is as it's coming down, it gains heat. When you compress a gas, it heats up. For the pressure. The pressure, as you compress a gas, it heats up, right? You know how, like, if you let out the stuff out of your spray can too fast, it cools off? Reverse is true too. If you push it back in too fast, it heats up. And so what this does, that's how a heat pump works, and that's how your air conditioner works. This makes that temperature difference much larger, which means we can pull a lot more energy out. So we've gotten rid of the big pipe, which you can't afford, and replaced it with two small ones that we can afford. We have added a big compressor for the CO2, but other than that, we're making 3 times the power. We're actually making 5 times the power, but the parasitic loads take some of it away. So we've reduced the cost and doubled or tripled the power. That's the patent that we just filed. And so with that one, we've not filed, we've got it. We've got the patent on that. As of March, it was published. And so that's the technology aspect of what we're doing.
Okay. And is that then, so you said being able to share that across multiple installations. So is that one unit then, the energy produced out of that, is that shareable then, or where does the linkage and the sharing come in?
Here's the thing about that concept about sharing the platform. No matter how good anybody's technology gets, and to be honest, this EOTech, as we call it, an enhanced OTEC, will be better than anything that's out there. Even it will do better economically if it shares the platform cost with a big wind turbine and wave energy devices and all these other things that it needs, right? So it doesn't matter how good you get, you're always better to share. It's like kindergarten playing in the yard. You'll all do better if you share.
Right. Okay, I get that. Yeah, that's good. So I'm sure that there's a fair amount of data that's generated by that's used maybe by other systems external to yours, or even just within your operation. How does that?
I've had people talk about how you control the data, in particular how you can control mixing the power systems, because that tends to make some people nervous, but they tend to be people who really don't know how these things work. Because I'll give you an example of the wind turbine. When a wind turbine, the wind's changing speed the whole time, and so what comes off of that generator is what they call wild AC. It's AC that's it's all over the place. So the first thing they do is convert it to DC, and then run it through an inverter to turn it back into AC at the perfect 60 hertz or 50 hertz, depending on where you are in the world, right? If instead of doing that, you take it at that DC level and you put them all together, as long as they're set to the same voltage, if I've got a little tiny kid's windmill in my hand and it's making power, and I've got the big one over here and it's making power, as long as they're set to the same voltage, the fact that this one's making almost nothing in terms of amps, and this one's making 5,000 amps, that doesn't matter. They'll go right together. In the DC level, voltage is like pressure in a pipe, and amperage is the flow rate. That's the only difference. So it's just like if you're hooking up a couple of pipes. If I've got a big pipe, as long as the little one hooking into it's at the same pressure, it all flows in the right direction.
So you had mentioned in our previous conversation a little bit about project management. So you're having to manage some big projects.
I have not in the renewable space, but I have in oil and gas. Yes.
Right. So tell us a little bit about your experience. So a lot of our listeners, business leaders that are getting involved in various size projects, some of them big, some of them small. But if you were giving advice to the average small business owner and they wanted project management advice, what's maybe a couple of key points that you might share with them?
Al, the first thing is that there's lots of books and lots of courses, and you can get it's called a project management certificate and all kinds of things, a PMP from the Project Management Institute. The fact of the matter is, managing a project is very dependent on what kind of project it is and what your environment is and how much is at risk. So, for example, when I was working offshore, we would spend years, 3 to 4 years, getting ready for 90 days worth of really intense work. Because if you make a mistake at that part of it, that's $1 million a day. Right? So you can't have anything go wrong there. That's a different level of organization and process and all those things you have to have, and quality control, and you always have to have a spare and all those other good things. If I'm doing that same exact kind of thing, like I'm building a pipeline onshore, it's not quite as important. Because if say I messed up and I bought the wrong valve, we just keep working on the rest of it while they go to the store. They get a new valve, they bring it on the truck, and they put it in. As long as you get it there before the pipeline's done, you're good. When you're working offshore, you can't do that. So again, that's one step down. And then if you go to building a house, again, you're one step down below that. And if you're starting up a small business, if you're doing this, if you have a construction firm or something, again, you want to have a process. And that's all project management really is when they talk about how to do it. It's having a process that you use so that when you make a mistake, you can make sure you don't do it again. A lot of people think that the process is meant to be perfect the first time out. You're trying to get it perfect, and you're not. What you want to do is, this is what I think we should do. And then you go do it, and you have to have the second process you write right after you write the first one that tells you how to do it is how to keep track of the changes and the things that went wrong. And most companies are really good about the first one, and they're kind of good about writing the second one, but they're really bad about taking the information from the second one and putting it back into the first ones.
Yeah. That's true. In my experience, so there's two things that normally get left off on an IT project. So they'll talk about it, but and everyone knows it's important. But two things. One is the postmortem. So what you're talking about, coming back at the end and saying, here's all of the things that, could have been done better. Here's how we can improve on the next time. And the other one is technical documentation. Right? So it's one of those things that, it will pay you dividends in the future, but it's hard to put an ROI on right that minute. Right? But if you don't do that, especially like the documentation, is when you come back later when you need it, it's too late. It's too late for the most part.
I've been involved in the implementation of IT projects for several times, including a massive document control one. And that when I was managing it, I made the contractor a little crazy to start with, but by the end they were right there with me. They walked in and I said, great, wonderful. I says, who's the last company you did this for? And they told me. I said, good, we'll take it. I said, change the names, give it to us. Oh, no, we have to have your process. I said, we don't have a process. I said, well, let me rephrase that. I said, we do have a process. We have a process, and the group over there has a process, and that group over there has a process, and they all got their own process. I says, and the problem is they don't have a process. So they're going to have to change anyway. Then we'll just take whatever you just did that works, take the product works, give it to us, and then what we're going to spend our time on is writing that second piece, which is how to manage the things that didn't work for us, and we're going to have to change it the next go around. So that was the first thing I told them. I said, and the second thing I did that made them crazy was I brought in, and I had, they had all the execs and stuff in there, but I also brought in the secretary. And I said, when we're done, I says, when you get your proof of concept all ready, I said, this is the person who has to use it. And they said, but this is for technical document. I said, I know. I said, so if she can use it, everybody can. I says, I want you to write it for her. It was a her in this case. Write it for her, and if she can use it, then it's good to go, and the technical guys won't have any trouble with it whatsoever. I says, if you write it for a technical guy, he's going to say, oh, I want this and this and this, and all these little things that he wants that he probably doesn't need. And then if he's not around, nobody else can use it. So you want to take it to the lowest possible denominator of who's going to be your user, and make it so they can use it, and then you're good.
Right. Well, the other thing that we always that's a best practice. It's not anything new by any stretch of the imagination, but you never want the developer to be the tester. So it kind of falls into that concept. If someone else can go test it and prove that it works out, other than the person that built it, then we've got a pretty good shot at having something that we can work with going forward. So I kind of get the concept of, we're going to pull in somebody else that may even be unfamiliar with the process.
No idea what you're supposed to be doing.
Yeah, but if that implementation, if that software, if that process that you put together, if they can follow that and be successful with it, then you're spot on. Then now you can that's a scalable item, right? You can now bring in whoever you need to, and you know that the capabilities there to be able to.
Well, plus I know this is meant to be a single system, as a document control system for the whole entire company. So then I also know that the lawyers can use it, the engineers can use it, the downstream guys can use it, the managers in the field can use it. You try to keep it as simple as possible. When we did the actual proof of concept, that's exactly who we had in the room. We had people from all those groups, and basically it was, I don't want to hear what you want to hear. I want to hear, does this do what you need? Yeah,
exactly. And the other piece that I don't want to lose track of that you were talking about earlier is what I would call risk management, right? So you need to understand those risks. And, my message to business leaders that are looking to implement technology is don't plan for the perfect world. So that feel-good path, you're not always going to have that. So, what happens if you don't have internet available? What happens if
you get hacked?
Yeah, exactly. What's the plan? How do you mitigate for that? How do you manage that risk? You just have to have those plans in place. And kind of to your point about bringing in people that are not trained in that process. So what happens if the people that normally work that process are all of a sudden not available for some reason? How are you going to fill in, and who's going to do that? So all really good stuff. And it's important to have those things in mind as you're pushing through a project. So to our audience, make sure that you like and subscribe. This is great information that Roy's sharing with us from his experience. And, by doing that, you'll be notified of any future videos that come up. And by the way, if you have questions about this, risk mitigation, how to manage projects, be sure and connect with me on LinkedIn. We'll be happy to help you. Now, if you're looking to implement offshore rigs and wave technology, you need to connect with Roy, okay? So, Roy, you've got this technology that you just patented. Is there something else coming down the pike that maybe you can give us a little tidbit on?
Not really in terms of that. I'm having enough trouble with just the two I already got out there. We have a whole book of things that we will patent as we go along the way, but those aren't protected, so I don't talk about them. But the things that, a lot of these things that I'm telling you in terms of the integration, that's not even really a patentable thing, right? Now we have a patented platform that has some unique qualities to it, but the concept of integration is the part that I always kind of proselytize. That works. It doesn't have to be our platform, but the one thing that doesn't work is when they go out there and, like, I'll give you an example. You're familiar with floating wind? Floating wind farms.
I mean, I know that much, so
there aren't a whole lot of people working in that particular field, so don't feel bad.
Yeah,
but it's like a lot of things. The focus, if they got this very large wind turbine, they're much bigger than the ones that are onshore. If you've ever seen an onshore wind turbine, the ones offshore are about twice as big. So they're big. They're so big that they have to make the blades in a port because they can't transport them to get to a port. So they make them port side and they go out. They're 110 meters long, I think, are the biggest ones now, each. So they put this on a floating platform. And the big focus has been for the last 5-10 years to how small can I make the platform? Because that reduces the cost, right? So how can I build the smallest, lightest platform I can to hold up that wind turbine? And when somebody says it like that, it sounds like a good idea. But if you run the numbers on it, it fails what I always call the fairy godmother test. So I'll take every technology, and if the fairy godmother came and this is what I'm working on, and she went, ding, I've given you the perfect solution, which in this case would be a platform that costs zero, right? So I've got a platform, cost zero, totally capable of holding it up. What does that do to my economics? And the short version is not much. So I'm working on a self-limiting solution because it can only get so small, right? I mean, it has to be big enough to hold the thing up. And even if I get it perfect, fairy godmother, all I do is I've reduced the electricity I was going to sell for 22 cents to 20 cents per kilowatt hour, which doesn't get me where I need to be. So that tells me that's not the right approach. And you can do that same thing with the wave energy devices and the tidal devices. And there are cases where those things work very well on their own, especially the wave and the tidal, if it's for supporting like a small community up in Alaska, where they need something small that they can take care of themselves. It goes in the river, run the river stuff, good stuff. But if you're trying to do utility scale, I want to power New York City, then you want to have big platforms like we do, like oil and gas size platforms. Now they're much more expensive. They are more expensive, but they carry so much more that you make more revenue. The kind of scale. I mentioned I also work in the blue economy because blue economy is basically anything else you do offshore besides energy. And once you've made that jump that I'm not going to go this tiniest little platform I can, and you've got this whopping great monster like mine is, what you end up with is a thing that can carry aquaculture, mineral extraction from the seawater, hydrogen production, power to fuel production, marine science. You can do anything you want. I've got 12,000 tons of payload. I can put whatever I want on there.
Mm-hmm. Wow. So it kind of gets back to your old concept about sharing, right? Yeah, that whole sharing thing kind of comes back into play again, doesn't it?
I make it akin kind of to like if right now what they're doing is they're buying one car to take their kids to school and another car to go get groceries and another car to go to work, and you can do it that way. It'll work, but it's awful expensive.
Sure it is. Yeah, absolutely. So I've got to ask, one of the questions we typically try to get to on every podcast is the whole AI question. So what are your thoughts on AI? Are you implementing it? Is it in the future for you? Give me your thoughts on that.
Where AI will be most useful in what I do in particular for the offshore renewables, and what it will be good at, is when they start talking about integrating these systems, and when you talk about even just modeling these things, the interactions between the turbines and the platform and the waves and the currents and all these things are really hard, right? CFD kind of stuff. And I kind of smile because I'm old school, and so when it's really hard to do it there, just go stick it in the ocean and see what happens and adjust it, right? That's the Elon Musk way of building a rocket, build it if it blows up, build another one. There's a lot more to it than that. Don't get me wrong. I'm just oversimplifying. But there is a tendency to want stuff not to fail the first time out the door. But AI will allow us eventually, once it's collected enough data, to make far more accurate predictions on these things. And it will also be able to analyze. We're collecting more data on the oceans now, like on a monthly basis, than we've had over the entire history of collecting the data for the ocean. Because of all these they have little robots now all out there measuring stuff and scanning stuff and doing all kinds of things. Right now, that data is all over the place. Eventually, if it gets collected into one spot, that's going to be a really powerful tool. But that will take something like an AI to pull any useful information out of it.
And same thing about the platforms that you're putting in place or the other apparatuses and technology that's going onto those platforms is you have to collect some of that data before you can start modeling on it, right?
Yes and no. The way test tanks work is you put things in, right? So you create like a wave that goes in. And that's actually one of my minor issues I have with the way that we test and design some of these things. I pointed out to the school I went to, which was Texas A&M Galveston, which is the maritime school. I'm a marine engineer by training. Rather than build a big test tank, in today's world, we have so many sensors and things we can put on these things, is to build your model and take it and put it out in the real ocean. Have a place where you can just hook it up, have a permanent anchor line and hook the sucker up and just measure all of the data coming in other words, what the waves and the winds and everything else are doing coming into it, and then see how it responds. Because that will be the chaotic environment that it's going to see in the real world. When we used to do this stuff by hand,
Right, exactly. Yeah, okay. Well, that's interesting. It's always good to hear different approaches and different thoughts on how folks are going to use that technology going forward because it seems like everybody has a little bit of a different take on it. So one other thing that we try to talk about a lot is about high performance teams, very highly skilled and technical folks. First of all, how do you, number one, get them to join your team? How do you recruit?
And then I found bribery works best, but yeah, I don't.
Well, yeah, I mean, I get that, and that can be one of the inducements, right? So kind of expand on that a little bit. So, what are your thoughts about how you do that? How do you manage your teams?
Oh, and again, you get your mind warped a little bit when you work offshore because the numbers are bigger than usual. It depends on what kind of team you're building, and it depends on what the project is. Again, if this is going to be a long-term team, if you're building a company and you want these people to be with you for 10, 15 years, then how well they fit and how well you get along with them is very important. I'll be honest and tell you that a lot of the people that I would hire to do a project for me offshore are right fine pains in the butt. You wouldn't want them around any other time. But they knew their stuff inside, outside, upside, and down. And so no matter how obnoxious they could be in terms of their social and their emotional intelligence levels was about a 0, they would get the thing done that needed to be done. And again, when you have those kind of dollars at risk, that outweighs just about anything else. But that's a very rare occurrence. Right? These are exceptional people in an exceptional situation. If you're building a team, though, that's going to be working together for a long time, then again, it's going to be a fit in terms of how well do they share your goals? Do they share what you want to do? And attracting good talent, if it's something that's interesting, is not hard. If you're trying to attract good talent and you're setting up a competitor to Starbucks and you want people to be baristas, that's a whole different kind of problem, right? And that goes back quite literally to bribery. And I say it that way, but it's the pay makes a big difference. I remember my wife used to work for a company that did it was direct mail, kind of a low rent marketing firm, right? And their turnover was zero. But only because they paid about 20% more than their competitors in terms of their salaries, but the salaries were low, so we're not talking a large amount of money here. But more importantly were the benefits and things that they had. And like their Christmas party, I used to go to their Christmas party. Their Christmas party was better than any of the oil and gas ones that were put on. Live band, and they'd give away a big screen TV. I remember one time they gave away one of those TVs that nobody uses anymore, the ones that are about the size of a house.
Oh, yeah.
Yeah. Big projection TVs.
TV, yeah.
Right. Yeah. But in fact, they could probably use those to take care of most of the homeless now. They could just stick those outside and give them plumbing, and you'd have something.
There you go.
But those kind of things built a loyalty into what would normally be kind of a lower end kind of business. And those little extras make all the difference if you're trying to retain and keep people. That's my take on that. But I guess as far as attracting the talent, they're either attracted to the job, or attracted to the pay, or it's a personal connection that you know them and they want to work with you. And sometimes it's all of the above.
Right. Well, Roy, really appreciate your insight and sharing so much about your business, and you're kind of unique for our audience anyway. A little bit
that's the same thing my kids say.
Yeah. But we appreciate you sharing that. And why don't you share with the audience how they can stay in touch with you and kind of follow what you and your organization is doing?
I mean, the easiest way to connect to me is on LinkedIn. You'll find me there, annoying lots of people. If you want to look up our website, it's just www.excipio Energy. That's EXCIPIO Energy, all one word, .com. It's a little out of date. Doesn't have. We're in the process of updating it, but that'll get you kind of a broad view. Plus, I think it's still got the Mystery Science Theater 3000 version of our video. using the models you built in the garage and moving the legs back and forth with fish line. That's good.
Right. Okay. That's interesting. I might go check it out just to see the imagery.
If you have a certain age, you'll know who that was.
All right. Well, thank you, Roy. We really appreciate you being on, taking the time. To everyone in the audience, make sure that you follow us and watch for new videos coming up. We've got some great guests, kind of like Roy here, coming up. So do that. And until then, take care, and we'll see you next time.